There is a thin, dark line in the soil, no wider than a hand, and beneath it the world was warm. Above it, the cold came back. This is not a story about a war or a king or a city that fell. It is a story about a seam in the earth that appears on 3 continents at the same depth and the same age, and about the question that no one, after a century of digging, has been able to answer. Something happened around 12,800 years ago. The great thaw that was lifting the planet out of its last ice age simply stopped. In the span of a single human life, perhaps less, the temperature over the northern world fell away, as if a door had been closed against the sun. Forests became tundra. Rivers froze that had begun to run. The animals that had survived 100,000 years of ice did not survive this. And whatever caused it left almost nothing behind except that dark line, and a scattering of strange grains inside it, and a silence where the answer should be. We call the cold that followed by the name of a small white flower. We still do not know what pressed the world back down into winter. If you can feel this calm slowly carrying you off, press like before it does, and stay a while with a subscribe, but only if something in these words holds you. Tell me, if you wish, from which corner of the world and at what hour you're listening. It comforts me to think of all the others who are still awake in this same hour. To understand the size of what was lost, it helps to remember what the world had been doing just before. For thousands of years, the ice had been retreating. The great sheets that had buried Canada and Scandinavia were thinning, groaning, giving back the land they had held. Meltwater ran in braided channels. Grasses pushed up through ground that had not seen open sky since before the first cave paintings. Herds moved north into the newly bared plains. It was, by every measure the sediments can offer, a world exhaling after a long-held breath. And then that breath caught. The recovery did not slow gently the way a warming climate might be expected to ease. It reversed. The pollen buried in the mud of European lakes tells the reversal in a language that does not lie, because pollen does not care what any later century wants to believe. In layer after layer, the grains of warm, loving trees give way, almost overnight in the reckoning of geology, to the grains of a cold-ground plant that had no business being there. That plant is why the whole episode carries the name it does. Everything else about it remains open. The dark seam is only the beginning of the strangeness. The flower is called Dryas octopetala, mountain avens, a low white bloom with 8 petals that grows where almost nothing else will. It clings to Arctic slopes and to the cold, stony ground at the edges of glaciers, and it asks for very little except that the world stay frigid. When the botanists first read the old Scandinavian lake beds, they found its pollen surging up in a band that sat squarely on top of the warming trend, as though the cold had reached down and planted a garden that should not exist in a world that was supposed to be getting warmer. They named the whole interval after it. The Younger Dryas, they called it, to set it apart from an older, shorter chill that had come before. But a name is not an explanation. Naming the cold after the flower that thrived in it is a little like naming a wound after the scar. It tells you the surface of the thing. It says nothing about the blade. And the pollen record, for all its patience, could only mark when the cold arrived and when, more than 1,000 years later, it left. It could not say why the flower was summoned, or why, after gripping the northern world for roughly 12 centuries, the cold released it just as abruptly as it had begun. The mountain avens still grows in the high cold places. It carries no memory of what it once meant. To learn how fast the cold actually fell, the scientists had to stop reading flowers and start reading ice. Ice keeps a more exact ledger than mud. In the great ice sheet that still covers Greenland, snow that fell in a single year is pressed into a single thin band, and the bands stack downward through the centuries like the pages of a book no human hand wrote. Drill a core, lift out a cylinder of that ancient ice, and each layer holds the chemistry of the air on the day it fell. The ratio of certain oxygen atoms trapped in the frozen water rises and falls with temperature. so that reading down through the core is like reading down through time itself, degree by degree. When researchers pulled long cores from the Greenland summit and counted their way back to the boundary, they found something that unsettled even the people who had expected a sharp change. The plunge into the Younger Dryas was not gradual. In places, the record suggests the northern climate reorganized itself within a decade, perhaps within a few years.
A world can take an ice age to build and let it go over 10,000 slow summers. This did the opposite. It slammed shut. And near the very bottom of that plunge, in the ice that fell as the cold took hold, the instruments found a trace of something that does not belong in snow at all. A metal. A faint, insistent spike of an element that the surface of the Earth carries only in the smallest amounts, and that arrives, when it arrives in quantity, from somewhere else entirely. The metal was platinum. On the surface of our planet, it is vanishingly rare, hoarded deep in the core where the heavy elements sank long ago, so that the crust we walk on holds almost none of it. But platinum is common in a certain kind of visitor. It rides in metallic asteroids and in the dusty hearts of comets, and when such a body burns or shatters in the sky, it can salt the ground beneath with a chemical signature that is difficult to explain any other way. In the Greenland ice, right at the onset of the cold, the platinum climbs into an anomaly sharp enough that researchers went looking for it elsewhere. And they began to find it. Not only in the ice but in the soil, at that same dark boundary, at sites scattered far apart. A layer in Greenland and a layer in the American plains and traces across parts of Europe and the Near East, all sitting at the same moment in time, all carrying a whisper of the same off-world metal.
This is where the story stops being a curiosity about a flower and a cold snap and becomes something harder to look away from. Because if a single event laid down that seam across the northern hemisphere, then whatever it was very large and very fast, and it happened to a world that was already full of living things. The animals beneath the dark line tell the next part. There are a great many of them, and above the line there are almost none.
Walk the exposed banks of certain streams in the American Southwest, and you can see the seam with your own eyes. A band of dark organic-rich sediment that geologists took to calling the black mat. It forms a floor. Below it lie the bones of a lost menagerie, the great animals of Ice Age North America packed into the older layers like a bestiary sealed under glass. Columbian mammoths taller than the tallest modern elephant, mastodons with their heavier, forest-browsing tusks, giant ground sloths that reared up to strip leaves from trees, dire wolves, the short-faced bear that could look a standing man in the eye, native horses and camels that had evolved on this continent across millions of years. Above the black mat, in the sediment that settled after, those bones are almost entirely gone. Not thinned, not reduced, gone. Something like 36 genera of large animals vanish from the North American record in a geological instant that sits again on that same boundary.
The great herds that had shrugged off ice age after ice age, that had walked through the teeth of the coldest millennia the hemisphere could throw at them, disappear at the exact horizon where the platinum spikes and the cold slams down. It is one thing to read a temperature drop in a column of ice. It is another to stand on a riverbank and put your hand on the layer beneath which an entire living world lies buried and above which it does not. The black mat does not argue. It simply divides the before from the after and dares anyone to explain the width of the wound. And there is a further detail, easy to pass over, that turns the whole scene stranger still. In some of these sites, the ones who hunted the great animals disappear from the record too, at the very same depth. The vanishing of the giants was not merely a subtraction of species from a list. It was a wound to the whole living fabric of the land, and its consequences rippled outward for thousands of years after the bones went silent. Animals of that size are not passive occupants of a landscape. They shape it, remake it, hold it in a particular form by the sheer fact of their appetite and their weight. Mammoths and mastodons knocked down trees and trampled brush. keeping vast tracts open as grassland where forest would otherwise have closed in. And their dung carried and fertilized seeds across enormous distances, stitching the plant communities together in ways no smaller creature could replace. When they were gone, that stitching came undone. Woodland crept into the open country the great beasts had kept clear. Certain plants that had leaned for their whole existence on huge animals to swallow and scatter their seeds, fruits grown too large for anything now living to eat, were left stranded, their partners extinguished, some of them surviving to this day only as puzzles, oversized fruits with no animals suited to spread them, the marooned relics of a bargain that ended at the boundary. The predators and scavengers that had lived upon the herds followed them down into absence. The dire wolves, the great cats, the vast soaring birds that had circled above the moving masses of flesh. An entire architecture of life, assembled over millions of years around the presence of the very large, came apart in the width of that dark layer. And what grew back in its place was a thinner, quieter, simpler world. When people speak of what was lost when the last age ended, they reach most often for grand and human things. A civilization, a body of knowledge, an answer to the riddle of the cold. But the plainest loss, the one written most legibly in the bones beneath the black mat, was this living one, the great emptying of the world's largest animals.
A diminishment so total that no human being has ever walked through a landscape with them in it, and we can scarcely picture what such a walk would have been. And the strangeness only deepens when the record reveals that the people who hunted those animals faded from it at the same moment, leaving behind a signature as distinctive as any bone.
The hunters had left a signature as distinctive as any animal's bones. Across North America, from the plains to the eastern woodlands, archaeologists kept turning up a particular kind of spear point, beautifully worked, leaf-shaped, with a distinctive channel or flute flaked up from the base so the point could be seated on a shaft. They named it for the New Mexico town near where it was first recognized. Clovis, they called the points, and Clovis the people who made them, and for a long time, the Clovis were thought to be among the founding cultures of the peopled Americas. Their tools appear across an astonishing sweep of the continent, made to a shared design, as if a single technological idea had swept from coast to coast in a matter of centuries. And then, at the boundary, the Clovis toolkit falters and fades. The classic fluted points stop being made. The cultures that follow are different, more regional, more scattered, as if some connecting thread had been cut and the survivors had to begin improvising separately in a colder, emptier land. It is possible to tell this as a simple story of prey and predator, the animals dying and the hunters who depended on them scattering after. But the timing refuses to stay simple. The great animals, the founding human culture, the warm climate itself, all falter in the same thin band of earth. And so the question that began as a curiosity about a flower has grown teeth. What could reach down and still the hunters and the hunted and the very warming of the world all at once, all in the same held breath of geological time? A slow climate shift does not do that. Slow shifts give animals room to migrate, cultures room to adapt, the record room to blur. This did not blur. It cut. And the men and women who first proposed an answer to that cut were not looking for a flower or a spear point at all. They were looking under the microscope
At what the black mat itself was made of. Under the microscope, the black mat and the boundary sediments gave up something no ordinary layer of dirt should contain. In 2007, a group of researchers put forward a claim that split the field and has never fully healed. Sifting the boundary material, they reported finding tiny spherules of once molten rock and metal, magnetic grains flecked with unusual chemistry, glassy carbon and, most provocative of all, diamonds so small they are measured in billionths of a meter, nanodiamonds, the kind of mineral that forms under sudden, brutal pressure and heat. These were not the diamonds of jewelers, they were the diamonds of catastrophe, the signature of matter squeezed and scorched in an instant, and they appeared, the researchers said, concentrated in that same thin band across dozens of sites at the onset of the cold. From this, they drew a conclusion large enough to reorder the whole story. Around 12,800 years ago, they proposed a comet or asteroid, or more likely, a swarm of fragments from a single disintegrating body struck or exploded above the northern hemisphere. Not necessarily a single crater-blasting impact, but perhaps a cluster of airbursts, bodies detonating in the atmosphere with the force to scorch continents, throw up a veil of dust and smoke, ignite wildfires across vast regions, and destabilize the ice sheets themselves. The heat would explain the spherules and the melted glass. The dust and soot would explain the sudden cold, a nuclear winter written not by human hands but by the sky. The ecological blow would explain the vanished herds and the scattered hunters. It was, if true, one of the most consequential events to befall the living world in the whole span of human existence, and it had left its evidence not in legend, but in the ground beneath our feet. The trouble is that a claim this large demands evidence this large held up to the harshest light.
And when other laboratories went looking for the same grains, the story fractured almost as violently as the comet was said to have. Some found the spherules and the nanodiamonds. Others, working what they said were the same layers, found little or nothing, or found grains they argued had ordinary origins, wildfires, volcanic dust, contamination, the slow chemistry of soil. The signature that was supposed to settle the matter became the very thing that divided it. And beneath all the argument lay a simpler, harder objection, the kind a child might ask. If something struck the Earth hard enough to end an age, then where, on the whole face of the planet, is the hole it made? For years, that absence was the impact hypothesis's deepest wound. A comet large enough to reset the climate should have punched a scar into the crust that any survey could find, and no such fresh scar of the right age and size sat conveniently on the map. Then, in the second decade of this century, a survey flying instruments over the Greenland ice sheet turned its radar downward and read the shape of the bedrock hidden beneath nearly a kilometer of ice at the edge of the Hiawatha Glacier. What the radar drew was a near-perfect circle, more than 30 kilometers across, with the raised rim and central rise that planetary scientists recognize instantly, because they have seen the same form 1,000 times on the cratered face of the Moon. It was an impact crater, one of the largest known on Earth, and it had been hiding under the ice at the top of the world, unseen because no human eye can look through a kilometer of frozen water. For a moment it seemed the missing hole had been found. Here was a wound of continental consequence, buried in the very region the hypothesis pointed toward, in ice that had begun to destabilize at just the wrong time. The excitement was immediate, and so was the caution, because a crater's shape can be read from radar, but its age cannot. To know when Hiawatha was born, researchers had to gather the sand and rock that meltwater had carried out from beneath the glacier, grains that had been heated and reset by the impact, and coax a date from them using the slow radioactive clocks locked inside. When those dates came back, they did not say 12,800 years. They pointed instead to a catastrophe far older, tens of millions of years into the deep past, long before any human walked the Earth, long before the flour and the ice and the black mat. If the dating holds, then Hiawatha is a genuine giant wound in the planet's history, but it is the wrong wound for this story. It fell in another age entirely, and the crater that would explain the Younger Dryas, if a crater exists at all, is still missing. Which returns the whole question to the ground, and to a place far from the ice, where a village on a warm river seems to have witnessed the moment itself and burned. On the banks of the Euphrates, in what is now northern Syria, there once stood a settlement that archaeologists call Abu Huraira. It is one of the most important places in the whole human story, because the people who lived there sat at the very threshold between two ways of being. They were hunter-gatherers learning tentatively to tend the wild grains that grew around them, standing at the doorway that leads from foraging into farming, from following the herds into settling beside the fields. Their village was later drowned beneath the waters of a reservoir, but not before its layers were carefully excavated and its samples carried away. And it is those samples that would, decades on, place the settlement at the center of the argument about the sky. Sifting through the material from the level that corresponds to the boundary, researchers reported finding melt glass,
small fragments of sediment and building material that had been heated to temperatures so extreme that the very minerals within them had fused and flowed. This was not the glass of a cooking fire or a burning hut. Ordinary fire, the fire of hearths and even of great conflagrations, cannot reach the temperatures these fragments seemed to record. To melt quartz, to fuse the grains of soil into flowing glass, you need heat measured in the thousands of degrees, the kind of heat that a hearth cannot produce, but that a cosmic airburst can. A body detonating in the atmosphere and pouring a wave of thermal energy down onto the ground below. The researchers argued that Abu Huraira had been standing in the wrong place at the wrong moment, that it had felt the touch of whatever descended on the northern world, and that its scorched glass was a fingerprint of that touch preserved in the layers of an ordinary village. If they are right, then this is one of the very few places on Earth where human beings may have lived through the event, where the people themselves, not just the animals and the ice, stood beneath the sky when it changed. The image is hard to shake. A community at the dawn of farming, learning the patient rhythms of seed and season, and then a light and a heat from above that the language of the time could not have held. And yet the melt glass, like the nanodiamonds and the spherules before it, has not compelled agreement. Other researchers have looked at the same kind of material and offered other origins, arguing that high-temperature glass can form in ways that have nothing to do with the sky. That ancient fires burning through certain fuels and structures can reach hotter than we assume. That natural processes and even the collapse of burning buildings can leave behind fused fragments that mimic the signature of an airburst without requiring one. Every piece of evidence that the impact hypothesis lifts up, its critics find a way to set back down. This is not the sign of a bad argument on either side. It is the sign of a question that sits precisely at the edge of what our methods can resolve, where the same grain of scorched glass can be read as the touch of a comet or the residue of a hearth, depending on which chain of reasoning you follow and which assumptions you are willing to grant. The people of Abu Huraira cannot be asked. Their village is underwater, their voices 12,000 years gone, and the glass they may or may not have watched form says only that something at some moment grew very hot. What makes the whole affair harder still is that there exists an entirely different explanation for the cold, one that needs no comet at all, no airburst, no scorched village, one that many scientists find quieter and more plausible than a rain of fire. It asks us to look not up at the sky, but down, at a vanished inland sea of meltwater, and at the great hidden circulation of the ocean that carries warmth around the world, and can, if disturbed, let it slip. As the ice sheets over North America melted, the water they released did not always run freely to the sea. Much of it pooled behind walls of remaining ice into lakes of almost unimaginable size, and the greatest of these was Lake Agassiz, a body of fresh meltwater that, at its height, covered more of the continent than all of today's Great Lakes combined. A shallow inland ocean held in place only by the failing dam of the ice itself. Fresh water and salt water do not mix easily, and the world's climate depends, more than most people ever pause to consider, on the way they refuse to. In the North Atlantic, warm salty water carried up from the tropics by the ocean's great conveyor gives up its heat to the northern air and, growing cold and dense, sinks into the deep and flows back south, drawing more warm water up behind it in an endless overturning that keeps the northern lands far milder than their latitude deserves. This circulation is powerful, but it is not invincible. It runs on the delicate balance of salt and temperature, and it can be choked. The conventional explanation for the Younger Dryas proposes exactly such a choking. At the boundary, the theory goes, the ice dam holding back Lake Agassiz failed,
and a colossal pulse of fresh, cold water surged out toward the North Atlantic, spreading a lid of lightness across the surface where the warm, salty water needed to sink. The overturning slowed or stalled. The conveyor that carried warmth north faltered, and without it, the northern world plunged back into cold. Not because anything struck it from above, but because the ocean itself had been thrown out of balance by the very meltwater that a warming world produced. It is an elegant idea. It requires no visitor from space, only the physics of water and salt and the known behavior of a warming ice sheet, and it fits the pattern of a northern hemisphere cooling while other parts of the world barely felt the change.
But the ocean explanation carries its own unsolved knots, and they are not small ones. For the meltwater story to work, the flood must have escaped by a route that carried it to the right part of the sea at the right time, and the geological evidence for that route has been surprisingly hard to pin down, with researchers arguing over whether the water drained east or north, or whether the outburst happened at quite the moment the cold began. There is also the matter of the platinum and the spherules and the scorched glass, which the ocean theory does not address at all, because a shift in circulation does not salt the ground with off-world metals or melt the sand of a Syrian village. And there is the deeper puzzle of abruptness, the way the cold fell within years rather than centuries, and the way it lifted, more than a millennium later, just as fast, as though the whole episode had a switch that something threw and then, long after, threw back.
A slowing conveyor can cool a hemisphere, but the sharpness of the edges troubles even those who favor it. So, the field is left holding two explanations that do not comfortably combine. One says the sky broke open and rained fire and dust. The other says the ocean quietly turned over in its sleep. Each accounts for some of the evidence and stumbles over the rest. And the honest position, the one that too rarely makes it into a confident sentence, is that after a century of flowers and ice cores and black mats and buried craters, no one can yet say for certain which of these is true, or whether the truth is some braided thing that includes them both, or something not yet imagined at all. The disagreement itself has become part of the mystery, and it is worth pausing to ask why a question with so much evidence has stayed so stubbornly open. The cold, for all its violence, did not fall evenly upon the whole planet, and the uneven pattern of where it struck hardest is one more clue that has never been fully read. The Younger Dryas bit deepest in the lands ringing the North Atlantic, in Europe and Greenland and the eastern edge of North America, exactly the regions most directly warmed by the ocean circulation that carries heat northward. Travel away from that basin and the signature softens and shifts. And at the far bottom of the world, in the deep ice of Antarctica, the record tells a nearly opposite tale, a warming in the south while the north plunged into cold, as though the two ends of the earth were joined by a great seesaw, one pole rising as the other fell. This bipolar seesaw is real and well documented, and it fits with unsettling neatness the picture of a stalled ocean conveyor, because when the northward flow of warmth falters, the heat that would have travelled north lingers instead in the south, warming the bottom of the world as it starves the top. It is among the stronger cards in the oceanic hand, this fingerprint of warmth redistributed rather than warmth destroyed. A veil of comet dust, one might reasonably expect, would dim the entire planet at once, north and south together. A stalled conveyor would rob one pole to feed the other, precisely as the ice at the two ends of the earth appears to record. And yet, even the seesaw refuses to close the case, because the two great explanations are not truly enemies, and a sudden blow from the sky could, in principle, have set off the very meltwater and the very stalling that then played out across the poles as this slow rocking of the world's warmth. The pattern narrows the field without clearing it, tightening the question by a further turn while still declining to answer, so that even the shape of the cold across the face of the earth becomes one more chamber of the same locked room. There is also the plain, frustrating difficulty of pinning the boundary precisely in time, and this difficulty, dry as it sounds, sits close to the heart of why the argument will not end. The chief tool for dating anything organic from this era is radiocarbon, the steady fading of a form of carbon that all living things take in while alive, and that begins to decay the moment they die, ticking down like a buried clock. But that clock does not run at a perfectly even rate across the centuries, and around the very window when the Younger Dryas began, it stumbles into one of its most treacherous stretches, a plateau where samples of genuinely different ages can return almost the same apparent date. Events truly separated by a century or two can be smeared together until they look simultaneous, and a single event can be spread across a range of years, so that the fine distinctions the whole mystery depends upon dissolve into a fog exactly where the eye most needs them sharp. This is no small technicality. The entire case for one sudden cause rests upon synchrony, upon the claim that the cold and the extinctions and the platinum and the scattered hunters all arrived together in a single narrow moment. And synchrony is precisely what the dating struggles hardest to demonstrate at the resolution the argument requires. If the events were genuinely simultaneous, a common cause grows hard to resist. If they were staggered, drawn out across decades, the picture loosens into something a slow process could account for without any visitor from space. And the instruments at the boundary cannot always tell those two possibilities apart, because the clock itself grows vague in the very years we most need it precise. So even the timing, the one thing that ought to stand firmest of all, carries its own haze, and much of the long dispute over cause is, underneath, a quieter dispute over whether the evidence is even sharp enough to fix the order in which the world came undone. Part of the answer lies in the nature of the evidence itself, which is faint, scattered, and easy to contaminate. A grain of glassy spherule, the width of a hair, pulled from soil that has lain open to 12,000 years of roots and rain and burrowing creatures, is a delicate witness. Two careful laboratories can process what they believe to be the same layer and reach opposite conclusions, one finding the boundary rich in impact markers, the other finding them absent or explicable by ordinary means. And both can be honest, because the sampling, the sieving, the very definition of where the boundary lies, leave room for difference. When findings cannot be cleanly reproduced, science does what it should do. It withholds assent. But there is another current running beneath the technical disputes, harder to measure and impossible to ignore, and it has to do with how the human mind, even the trained scientific mind, resists the idea of sudden catastrophe. For most of the last 2 centuries, the governing principle of the earth sciences was that the present is the key to the past, that the world was shaped by slow, familiar processes acting over immense stretches of time, the patient work of rivers and rain, and the drift of continents. This principle was hard-won and largely true, and it freed geology from an older habit of explaining every canyon by a biblical flood. But it hardened over time into something close to a prohibition. To invoke a sudden, violent event was to sound unserious, to reach for the dramatic where the mundane would do. And so a bias settled into the discipline, a quiet preference for the gradual over the abrupt, that made claims of cosmic catastrophe unwelcome long before the specific evidence for any one of them was weighed. The history of that bias has a name attached to it, and a lesson. In the early 20th century, a geologist named J. Harlan Bretz studied a vast region of eastern Washington state, a scarred and channeled landscape of dry waterfalls, enormous gravel bars, and canyons cut into solid rock. And he concluded, against everything his profession then believed, that this terrain had been carved not by slow erosion, but by a flood of almost inconceivable violence, a wall of water that had scoured the land in a matter of days. His colleagues rejected the idea with something close to contempt, precisely because it smelled of catastrophe, of the very sudden flood thinking that geology had worked so hard to leave behind. For decades, Bretz was marginalized, his channeled scablands treated as an embarrassment. And for decades he was right. The floods were real, the sudden emptying of another ice-dammed lake, and the evidence eventually became overwhelming. Late in his long life, the honors finally came, and the profession quietly admitted that the landscape had been telling the truth all along. The story of Bretts hangs over the Younger Dryas argument like a warning that cuts both ways. To those who champion the impact, it is proof that the establishment can be blind to catastrophe, that an unpopular idea can be true. To those who doubt it, it is no such license, because being persecuted is not the same as being correct. And for every Bretts who was vindicated, there are many mavericks who were simply wrong. What the story really teaches is humility. The Earth has, on rare occasions, done sudden and terrible things, and it has also worn away mountains grain by patient grain. And the hardest task in reading its record is to tell, without prejudice in either direction, which kind of story a given layer of rock is trying to tell. The boundary that carries the black mat may be one or the other. And there are places on the landscape, strange elliptical scars pressed into the ground by the hundreds of thousands, that some believe carry the imprint of the very event, if only they could be made to give up their age.
Along the Atlantic coastal plain of the United States, from the Carolinas down through Georgia and beyond, the land is dimpled with shallow oval depressions, hundreds of thousands of them, so regular in shape and so consistently aligned that they were noticed only when aircraft first photographed the region from above and the pattern leapt out of the flat green landscape. The Carolina Bays, they are called, elliptical basins with raised sandy rims, their long axes pointing with eerie consistency toward a common region of the sky. For as long as they have been studied, they have invited catastrophic explanations, and some who favor the Younger Dryas impact have seized on them as possible scars of the event, the marks left where fragments of a shattered comet or debris hurled up by an impact on the ice sheet rained down across the soft coastal sediments and gouged out these aligned ovals in a single terrible afternoon. It is a seductive picture.
And the alignment of the bays does demand some explanation, some organizing force that pointed them all the same way. But here again, the evidence resists the dramatic reading. When the ages of individual bays have been measured, they do not cluster neatly at the boundary. Many appear to be far older and to have formed and reformed over long stretches of time through the slow action of wind and water on the sandy ground, shaped by prevailing winds into their consistent orientation without any need for a rain of cosmic debris. The bays may be nothing more than the patient handiwork of climate and sediment, a pattern that looks designed only because natural forces, given enough time, can carve a startling regularity. Or they may hold, in some subset not yet properly dated, a memory of the day the sky came down. Like so much in this story, they hover between the ordinary and the extraordinary, refusing to fall cleanly to either side. What is striking is how often that is the shape of the whole affair. Every thread seems to lead toward the boundary and then fray just before it arrives. And so some who study the period have turned away from the physical scars entirely and looked instead at a stranger kind of record, one carved deliberately by human hands into pillars of stone on a hilltop in the highlands of the Near East, thousands of years before writing was supposed to exist. On a ridge in what is now southeastern Turkey stands Göbekli Tepe, one of the most confounding places human beings have ever uncovered. It is a complex of massive stone enclosures, great T-shaped pillars arranged in rings, many of them carved in relief with animals, foxes, boars, snakes, scorpions, cranes and vultures, rendered with a confidence and skill that should not exist at the time the site was built. And the time is the heart of the shock. The oldest layers of Göbekli Tepe reach back toward the very end of the Younger Dryas and the millennia around it, to a period when the people who raised these stones were supposed to be simple hunter-gatherers, without agriculture, without cities, without the surplus and organization that monumental building was thought to require. Yet here are pillars weighing many tons, quarried and shaped and set upright and adorned on a hill with no dwellings, apparently a place of gathering and meaning rather than daily living.
Built by hands that had not yet, by the old story, invented civilization. Göbekli Tepe alone forces a rethinking of when human beings became capable of great collective works. But some researchers have gone further and looked hard at one pillar in particular, a stone carved with a vulture and a scorpion and a disc and other figures, and argued that its images are not simply animals but a map of the sky, a record of the positions of certain constellations at a specific and terrible moment. Reading the carvings as astronomical symbols, they proposed that the pillar commemorates a date, and that the date it points to falls close to the onset of the Younger Dryas, as though the stone were a monument to the very catastrophe this whole story circles, a memory of fire from the sky set down in rock by people who may have survived it. The astronomical reading of that pillar is contested, as everything in this story is contested, and it should be held lightly. Skeptics point out that a scattering of carved animals can be matched to constellations only by choosing which figures to count and which to ignore, that the human eye is exquisitely good at finding patterns where none were intended, and that the people of Göbekli Tepe left no key to tell us whether their vultures were stars or simply vultures. To read a precise date into a Stone Age carving is to ask the stone to speak a language we cannot prove it knew. And yet the mere existence of the site presses on the imagination in a way the argument over its carvings cannot dispel. Here is monumental achievement at the wrong end of the timeline, sophistication where the textbooks predicted simplicity, and it sits squarely in the window of centuries during which the world had just been convulsed by the cold.
It raises a possibility that hovers at the edge of respectable inquiry and refuses to leave. What if the disruption itself was a kind of forge? What if the scattering of peoples, the collapse of the old hunting way of life, the pressure of a suddenly harsher world, drove the survivors together onto hilltops like this one, drove them to store grain and gather in numbers and raise stones, and so lit the first sparks of the settled, building, remembering kind of life we called civilization? On this reading, the Younger Dryas is not only an ending but a threshold, a violent gate through which humanity was pushed and came out changed, carrying forward some memory of what had happened, half in stone and half in story. It is a possibility, no more. But it reframes the whole question. If the world truly stopped 12,800 years ago, then we are not distant observers of the wound. We may be its children shaped in the aftermath,
the descendants of those who lived through the closing of that door.
The idea that the event might recur, rather than being a single freak of the deep past, comes from looking up at a particular river of debris that still crosses Earth's path each year. Streaming through the inner solar system is a broad, diffuse trail of dust and rock known as the Torrid Stream, and threading through it is a comet, faint and periodic, that some astronomers regard as the surviving core of a much larger body. The hypothesis, developed and debated over the last several decades, is that thousands of years ago, a giant comet wandered into the inner solar system and began to break apart, shedding fragments and dust into an orbit that the Earth still intersects, so that twice a year our planet passes through the debris of that ancient disintegration. Most of what we encounter is harmless, dust that flares as shooting stars. But within the stream, the argument goes, there may be denser knots, clusters of larger fragments, and when the Earth's orbit carries it through one of these knots, the sky can deliver not a gentle shower but a bombardment, a period of years or decades in which the chance of a significant impact or airburst rises sharply. On this view, the Younger Dryas onset was not a lone accident, but the worst of a recurring hazard, one encounter unusually severe with a stream of cometary debris that we have crossed many times before and will cross again. It is a sobering thought to carry into the quiet of a night. The same dark sky that has soothed sleepers for all of human history is also a place from which things fall, on a schedule too slow for any single life to notice and too fast, perhaps, for a civilization to ignore. Whether the Torrid Stream truly holds the memory of a world-ending comet or whether it is simply a modest trail of dust to which the imagination has attached a catastrophe remains, like the rest, unsettled. But it changes the texture of the mystery. It suggests that the wound of 12,800 years ago, if wound it was, may not be safely buried in the past at all.
There is a temptation, when the physical evidence grows ambiguous, to turn to the oldest stories human beings tell and to ask whether they preserve, in the distorted amber of myth, a memory of what happened. Across cultures separated by oceans and by thousands of years, the same broad shapes recur. A great flood that drowns the world and leaves only a remnant to begin again. A time when fire fell from the heavens and scorched the land. An age that ended in catastrophe, dividing a lost former world from the present one. These flood and conflagration myths are so widespread that they have long fascinated scholars, and it is tempting to read them as folk memories of real events, of rising seas and falling stars, handed down and dramatized across the generations until their origins were forgotten. But this is treacherous ground, and it must be walked carefully. Floods are common everywhere human beings settle near water, and the sky has always held meteors and comets.
So that stories of deluge and fire could arise independently in 100 places without any shared catastrophe behind them. The mind that finds constellations in a Stone Age carving is the same mind that finds a single cometary impact behind every flood legend, and it is just as likely to be fooling itself. A myth is not a measurement. It cannot be dated, cannot be cross-examined, cannot be made to say whether the flood it remembers fell 12,000 years ago or 1,200. And yet the sheer persistence of these stories leaves a residue that is hard to dismiss entirely. Something in the human record keeps returning to the idea of a world that ended and began again, of a former age washed away or burned. Whether that something is a true memory, or only the shape the mind gives to its fear of endings, is one more question this story raises and cannot close. The safest thing to say is that the myths prove nothing and haunt everything. The cold itself, whatever summoned it, did not last forever. After roughly 12 centuries of near-glacial conditions, the northern world warmed again, and it warmed with the same violence that had marked its cooling. The ice cores record the exit as sharply as the entrance, temperatures leaping upward in a span the record measures in years, perhaps in as little as a single human generation, as though the switch that had been thrown so long before was thrown once more in the opposite direction. With that second lurch, the Younger Dryas ended and the long stable warmth we call the Holocene began, the mild and forgiving interval of the last 11,500 years. The only climate settled agriculture and cities and written history have ever known. Everything human beings think of as civilization has unfolded within that warm window, which opened the moment the cold released its grip. It is worth sitting with the strangeness of that. The world we take for granted, the reliable seasons, the dependable harvests, the very possibility of building something and expecting it to still be standing for one's grandchildren, all of it rests on a stability that switched on abruptly at the end of an episode we cannot explain. Before the Holocene, the climate record is jagged and treacherous, lurching between states, and the Younger Dryas was its final and one of its most violent convulsions before the calm. Why the calm arrived when it did, why the wild swings gave way to 11,000 years of quiet, is bound up in the same unanswered questions as the cold that preceded it. We live inside the answer without knowing what the question was. And there is a further unease folded into the warming, because the rising seas that came with it swallowed enormous stretches of coastline that had been dry land when the world was cold, and no one knows what lies drowned beneath the waves that rose. When the ice was at its greatest, so much of the world's water was locked up in the great sheets that the seas stood far lower than they do today, in places well over 100 meters below the modern shore. Vast plains lay open to the sky, where there is now only water. Between Britain and the European mainland stretched a lowland now called Doggerland, a country of rivers and marshes and hills where people hunted and fished, its drowned floor still yielding worked flint and the bones of animals to the nets of trawlers. In Southeast Asia, a broad continental shelf joined islands that are now separated by sea, and around the northern rim of the Pacific, A land bridge connected Asia to the Americas, the road by which the first peoples are thought to have walked into a new hemisphere. As the Younger Dryas ended and the ice gave back its water, the oceans rose and took all of it, submerging the coastal lands where human beings had, in all likelihood, most densely lived, because people have always favored the resources of the shore. Whatever those coastal communities built, whatever they knew, whatever traces they left of the centuries around the Great Cold, lies now beneath the waves, out of reach of the spade, difficult and expensive to find and harder still to date. This is the quiet, deflating truth that underlies so much of the argument. The record we are fighting over is not merely faint. It is a fragment of a fragment, the inland scraps of a story whose most important chapters may have been written on coastlines that no longer exist above water. When someone insists that a lost civilization could not have existed in the depths of the last age because we have found no cities from that time, the drowned shelves offer a humbling reply. We have not looked where the people were. The absence of evidence across those submerged plains is not the same as evidence of absence. It is only the measure of how much the rising sea took, and how little of the world before the warmth we will ever be able to hold in our hands. Even on dry land, the passage of 12,800 years is a merciless eraser. Consider what must survive for us to know anything at all about a moment so remote. Organic material rots. Wood and cloth and flesh and story dissolve within centuries unless preserved by rare accidents of dryness or cold or airless mud. Stone endures, but stone is silent unless it was deliberately shaped, and even then the shaping weathers away. What reaches us across such a gulf of time is not a picture but a scatter of durable specks, a spear point here, a fused grain there, a spike of metal in the ice, a band of dark sediment, and from these specks we are asked to reconstruct the fate of a hemisphere. It is a little like being handed a dozen random pixels and asked to describe the photograph. The wonder is not that the story of the Younger Dryas remains contested. The wonder is that we can say anything about it at all. And this deep incompleteness is precisely what allows the argument to persist. Because with so few specks to constrain them, both the grand catastrophic reading and the quiet gradual one can be made to fit, each accommodating the handful of durable facts while filling the vast empty spaces between them with its own preferred story. The cometary version fills the emptiness with fire and dust. The oceanic version fills it with meltwater and stalled currents. The record itself, that scatter of surviving specks, does not yet contain enough to force the choice, and it may never contain enough because the layers that could decide it may have rotted or drowned or simply never formed. To care about this mystery is to accept a particular kind of vertigo. It is to reach toward a moment that changed the living world and to feel one's fingers close on almost nothing, and to understand that the almost nothing is not a failure of effort, but the ordinary condition of anything that happened long enough ago. One of the more haunting claims to emerge from the boundary studies concerns not metal or glass, but fire, on a scale difficult to picture. Some researchers examining sediments and ice from around the world reported a surge at the onset of the cold in the markers left behind by burning, soot, charcoal, and certain complex molecules that form when vegetation is consumed by flame. From these, they argued that an extraordinary episode of wildfire had swept across large portions of the continents at the boundary, that a significant fraction of the biomass of the northern hemisphere may have gone up in smoke in a short span of time, whether ignited directly by a cascade of airbursts or by the thermal pulse of a body detonating overhead. If such a thing occurred, the consequences would have been layered and terrible. The immediate fires would have devastated habitats and driven animals into flight and death. The smoke and soot lofted into the atmosphere would have dimmed the sun, adding a shroud of darkness and cold on top of whatever the initial event had already set in motion, deepening and prolonging the plunge. It is a vision of a world briefly on fire, and then, in the fire's aftermath, sinking into a long grey winter beneath its own smoke. But this claim, like its siblings, has drawn hard pushback. Critics argue that the fire markers can accumulate for many reasons, that natural wildfire is common in many landscapes, and its residues can concentrate in sediments through ordinary processes, and that a global synchronous inferno is a very large thing to hang on a scatter of charcoal and molecules. Whether the northern world burned in a single season or simply carried, as it always has, the ordinary background of fire is one more point where the same evidence supports two irreconcilable pictures. And so the pattern holds. Every dramatic thread, followed far enough, arrives at a fork where a mundane explanation waits beside the extraordinary one, and the record declines to say which path to take.
It is easy, amid the spherules and the ice cores and the competing models, to lose sight of the fact that this happened to people. Not to abstractions, not to a climate curve, but to living human beings with names we will never know, who woke one season to a world that had begun, inexplicably, to grow colder, and who lived out the rest of their lives inside a change they could not have understood. Whatever the cause, the human experience of the Younger Dryas would have been one of a world turning against them. The plants they had learned to gather thinned and failed. The animals they hunted grew scarce, then vanished. The mild seasons their parents had known gave way to a cold that did not lift with the years, that settled in for lifetime after lifetime. 12 centuries of a harsher world, longer than all of recorded history since the fall of Rome. Communities that had been drifting towards settlement and the first tending of crops were thrown back, or forced to gather in the few places that still offered enough to survive. Children were born into cold who would die in cold, having heard from the old ones stories of a warmer world they themselves would never see. This is the human weight beneath the geological abstraction, and it is what makes the mystery more than an academic puzzle. Somewhere in the ancestry of every person now alive are people who lived through this, who endured the closing of the warm world and, against the odds, kept the thread of humanity unbroken until the cold at last released its grip and the long summer of the Holocene began. We are here because they did not all die. And the not knowing, the great blank where the cause should be, means that we cannot even tell those ancestors what it was that fell upon them. We can only say that something did and that they survived it, and that the record of their ordeal has narrowed over the millennia to a dark line in the dirt and a handful of contested grains. To understand how a single violent event could cool a hemisphere for centuries, it helps to look at something better documented, a case where the sky darkened the world within living memory and the effects were written down as they happened. In the early 19th century, a great volcano in the East Indies erupted with staggering force, hurling so much ash and gas into the high atmosphere that a veil spread around the planet and dimmed the sun. The following year was remembered across the northern world as the year without a summer, a season in which frost struck crops in midsummer, harvests failed, snow fell out of season, and hunger followed in places far from the mountain that had caused it. That was the work of a single eruption, its cooling reach measured in a year or two before the veil settled and the warmth returned. Now imagine, on that same principle but vastly amplified, the dust and soot of a body detonating over the ice, or of a continent set briefly alight, thrown high into the air and spread around the globe, blotting the sun not for one summer but for a run of years, long enough to tip a world that was already balanced on a climatic edge, long enough to let the cold gain a foothold that other feedbacks, the growing ice, the changing ocean, could then lock into place for centuries. This is the mechanism the impact hypothesis leans upon, and its strength is that we know such cooling is real, that veils in the sky do chill the ground beneath, that a single event can reach down out of the air and starve the harvests of people who never saw its source. Its weakness is that the volcanic winters we can measure faded within a few years, while the Younger Dryas held for 12 centuries, which means a brief darkening cannot by itself be the whole story, only the trigger that sets some slower, deeper mechanism in motion. And the moment one admits that a slower mechanism was needed to sustain the cold, The door swings open again to the ocean,
and to the possibility that the sky, if it acted at all, only lit the fuse on something the sea then carried the rest of the way. In the years since the impact idea was first proposed, the argument has not so much resolved as evolved, with the ground shifting beneath the feet of both sides. Some of the boldest early claims have not held up under scrutiny. Particular markers that could not be reliably reproduced, particular sites whose dates were revised. And yet the case has not collapsed either, as its harshest critics once expected it to. If anything, one thread has grown sturdier with time. The platinum anomaly, that whisper of an off-world metal in the ice and the boundary soils, has been reported now from a widening circle of locations, and it is a harder signature to wave away than a contested sphereal, because platinum does not accumulate in soil through fire or ordinary weathering. A team of researchers assembling the evidence into a formal case has argued that the sheer breadth of the synchronous markers across many sites on multiple continents, all clustered at the same narrow moment, is more than coincidence can comfortably explain. Their opponents counter that breadth is not the same as proof, that a common date can reflect a common climate transition rather than a common impact, and that extraordinary claims still lack the single decisive piece of evidence that would end all doubt. This is where the frontier of the question genuinely sits today. Not in the certainty of catastrophe and not in its dismissal, but in a long, patient, unfinished weighing of grains and dates and anomalies by people who mostly agree on the facts and disagree profoundly on what the facts mean. It is not a comfortable place for a mind that craves an answer. But it is an honest one, and it has a strange dignity to it. The spectacle of human beings straining every instrument they possess against a moment 12,800 years gone, and refusing, most of them, to claim more than the evidence will bear. The mystery has not been solved, it has been sharpened,
which is a different and sometimes more valuable thing.
What would it take to finally settle it? The cleanest answer would be a crater, a fresh scar of exactly the right age and size, unambiguously the mark of a body that struck the Earth at the boundary. Hiawatha, hidden beneath the Greenland ice, briefly seemed to promise this before its dating pointed to a far older age, and the search for the true wound, if one exists, continues in the places hardest to look, beneath ice sheets, beneath the sea, in terrain that erases its own history. It is possible that a series of airbursts, bodies exploding in the atmosphere rather than striking the ground, left no crater at all, only the scorched and salted layer we already have, in which case the decisive evidence may never come, and the question may remain forever balanced on the edge of resolution. It is also possible that the whole cometary picture is a mirage, a pattern the mind has drawn across a scatter of ordinary points, and that the true cause was the quieter one all along.
The ocean turning over, the conveyor stalling, the meltwater doing its slow, cold work. The people who study this do not know which of these futures they are living toward. New methods may one day read the boundary layers with a precision that forces a verdict, or new sites may yield markers too clean to argue with, or the drowned coasts may give up a settlement that lived through the moment and recorded it. Or none of that may happen, and the Younger Dryas may take its place among the permanent mysteries, the questions that outlast every generation that asks them, handed down not as riddles to be solved, but as reminders of how much of the past is simply gone. For now, the honest map of the question has a hole in the middle, crater-shaped, and no one can say whether it will ever be filled. To grasp what kind of event this might have been, it helps to set it beside the other great blows the Earth is known to have suffered, because catastrophe has a range, and where the Younger Dryas falls within that range is part of what makes it so unsettling. At one extreme stands the impact that ended the age of the dinosaurs, a mountain of rock striking the planet with force enough to leave a crater visible from space and to close an entire chapter of life on Earth. That was 66 million years ago, so remote that it belongs less to history than to the deep architecture of the planet. Nearer to us lies the eruption of the Toba supervolcano, tens of thousands of years back, which some believe darkened the skies and stressed the young human species to the edge of survival. Nearer still, and gentler by comparison,
are events like the great submarine landslide off the coast of Norway that sent a tsunami across the northern seas and helped drown the low country between Britain and Europe. Against this company, the Younger Dryas occupies a peculiar and disquieting position. If it was an impact, it was smaller than the dinosaur killer, but it was far closer to us in time, close enough to have touched human beings directly, close enough that its effects are written not in the fossils of alien creatures, but in the tools and possibly the memories of our own kind. It sits in the narrow band where cosmic catastrophe and human history overlap, and almost nothing else does. That overlap is what gives the mystery its particular charge. A blow that fell before there was anyone to feel it is a matter of geology. A blow that fell upon people who were learning to farm, who were perhaps beginning the long climb toward everything we now are, is a matter of us. And to not know with any certainty whether such a blow occurred is to have a gap not merely in the record of the rocks, but in the story of ourselves. There is a place where scientists went to mark, formally and physically, the end of the age of wild swings and the beginning of the stable warmth we live in. They chose a section of ice from a deep Greenland core, ice that fell as snow in the very years when the Younger Dryas released its grip and the Holocene began, and they drove into that layer the equivalent of a boundary stone, a formal marker declaring, here, at this depth, in this frozen record, one epoch ends and another begins. It is a strange and moving thing to consider that the start of our entire settled era is pinned to a band of ancient ice, chosen because within it, the chemistry of the atmosphere leaps from the values of a convulsed world to the values of the calm one we know. On one side of that thin line lies the cold, the 12 centuries of harshness, the vanished herds, the scattered peoples. On the other side lies everything, all of agriculture, all of writing, all of the cities and the empires and the voices reading and listening in the dark tonight. And the marker sits precisely at the moment of the exit, the second violent lurch, as abrupt as the first, that returned the world to warmth. Yet the boundary stone records only the timing, not the reason. It says when the Wild Age ended. It does not say why it began or why it ended, or what the thing was that had thrown the switch 1,200 years earlier and now, just as suddenly, released it. To stand, in imagination, at that marker in the ice is to stand at the doorway of our own world and to look back through it at a darkness we cannot fully see into, and to feel the whole of human history balanced on the far edge of a cold we still cannot name. The gap in the record has drawn to it inevitably a bolder set of claims than the cautious ones of the laboratories. If a great catastrophe struck at the end of the last age, some have argued, then perhaps it did not merely scatter simple hunter-gatherers, but destroyed something greater, an advanced culture already flourishing before the cold came, whose cities and knowledge were wiped from the earth and drowned beneath the rising seas, leaving only faint echoes in later myth and in the sudden sophistication of places like Göbekli Tepe. It is a romantic and powerful idea, and it must be treated with both openness and rigor, because it makes a testable claim, and the test matters. The honest assessment is that no solid evidence for such a lost civilization has been found. The tools, the bones, the settlements from the depths of the last age are those of mobile foraging peoples, skilled and intelligent, but not city builders, and the drowned coastlines, for all they surely hide,
have not yet yielded the sunken metropolis the theory would predict. What the bolder claim mistakes, perhaps, is the nature of the surprise. Göbekli Tepe is astonishing not because it proves a lost golden age, but because it shows that ordinary hunter-gatherers were capable of far more than we credited them with. That monumental achievement did not require a vanished superculture, only human hands and human will applied at a scale we had not imagined. The truth, as far as it can be seen, is stranger and more humbling than the myth of a drowned Atlantis. It is that our own direct ancestors, the foragers of the last age, were fully our equals in mind and capability, and that whatever was lost when the cold came was lost from among people like them, not from some separate and superior race. The catastrophe, if it was one, did not erase a golden age. It fell upon the ordinary and extraordinary human world that was already here, the only one there has ever been. We watch the sky now in a way our ancestors could not, with instruments that sweep the darkness for the faint moving points of rock and ice that cross Earth's path, cataloguing the ones large enough to matter, calculating where they will be a century or 1,000 years from now. It is a young effort, only decades old, and it has already found many thousands of nearby bodies that no one knew were there. Most pose no danger in any time frame worth losing sleep over. But the exercise carries an echo of the old mystery, because the whole reason to watch is the recognition, hard-won and reluctantly accepted, that the Earth does occasionally intersect something in its path, and that the consequences, when it does, can reach from the sky down into the living world in a single day. Whether or not a comet ended the last age, the sky is unquestionably a place from which things fall, on timescales that dwarf a human life and yet fall well within the span of a species. The people who lived through the Younger Dryas, if they saw anything at all, would have had no framework to understand it, no word for a body from beyond the world, no way to know whether the light and the heat were the anger of a god or the indifferent physics of orbits. We have the words now, and the instruments, and the beginnings of understanding. What we do not have still is the certainty of what happened to them. There is something fitting in that. The same darkness that holds the answer also holds the ongoing question. The sky that may or may not have broken open 12,800 years ago, wheeling silently overhead tonight, above every sleeper and every waking watcher, keeping its counsel as it always has. To look up is to look at the crime scene if there was a crime, and to find it exactly as inscrutable as it has always been. There is a paradox at the center of all this that is worth naming plainly because it is rare. Most of the great mysteries of the human past are mysteries of absence, questions we cannot answer because the evidence has simply vanished, the records burned, the witnesses long dust, the sites unfound. The Younger Dryas is not quite like that. It may be the most heavily documented catastrophe in the entire span of time that overlaps with human existence. We have the flower in the lake beds, and the temperature in the ice, and the metal in the boundary, and the bones beneath the black mat, and the vanished spear points, and the scorched glass, and the drowned coasts, and the carved pillars, an abundance of evidence that most historical questions can only envy. And yet, with all of it in hand, we cannot say what happened. The mystery survives not because the evidence is missing, but because the evidence in all its richness points in more than one direction at once and refuses to converge.
This is a rarer and more disquieting kind of not knowing. It is not the darkness of an empty room. It is the confusion of a room so full of half-legible clues that no single story can hold them all. And it suggests something humbling about the limits of knowledge itself. That there exist questions where more evidence does not bring more certainty, where each new grain and date and anomaly, rather than closing the case, opens another door. The people who work on this have learned to live inside that condition, to hold competing pictures in mind at once, to follow the evidence without demanding that it resolve. It is a discipline that runs against the grain of how the mind likes to work, because the mind wants an ending, a verdict, a single true account. The end of the last age offers none. It offers only the seam in the earth and the long argument over what pressed against it, and the growing suspicion that the argument may outlast everyone now living and their children.
And their children after that. So what in the end can honestly be said? Only this, and it is not nothing. Around 12,800 years ago, the warming world reversed abruptly and fell back into a cold that held for roughly 12 centuries before lifting just as abruptly. This is certain, written unmistakably in ice and mud across the globe. At that same moment, across the northern hemisphere, a great many large animals vanished, A founding human culture faltered, and a thin, dark layer was laid down carrying, at many sites, a whisper of platinum that is difficult to explain by any earthly process. This much the evidence supports. Beyond it lies the fork that has never been passed. On one side stands the sky, a comet or a swarm of its fragments detonating over the world, salting the ground with off-world metal and scorched glass, dimming the sun with dust and smoke, ending an age in fire and then in the long grey winter of the fire's aftermath. On the other side stands the ocean,
a pulse of meltwater choking the great circulation that carries warmth north, letting the cold slip in without a single stone falling from the heavens. Each explanation carries evidence the other cannot claim, and each carries objections the other can exploit. And between them lies the crater-shaped hole in the middle of the question, empty still. We do not know which door the world went through. We know only that it went through one of them, and that on the far side everything we are was waiting to begin. The near answer, the closest thing to a resolution that a century of work has produced, is not an answer at all. It is a sharpened description of exactly what we do not know and why. And it may be that this is as close as anyone will ever come. Return for a moment to that dark band in the riverbank, because it is the one thing in this whole story that anyone can go and touch. The black mat is not a theory or a model or a contested grain seen only through a microscope. It is a physical layer in the ground, visible to the naked eye across the American Southwest and echoed in boundary sediments far beyond it. A horizon that a person can stand before and lay a hand upon. And in that simple act, the entire abstract argument collapses into something immediate and strange. Below the fingers, in the sediment just beneath the band, lie the last traces of the world that was, the pollen of warm plants, the bones of the great animals, the tools of the hunters who followed them. Above the fingers in the sediment just over the band, that world is gone, and a colder, emptier one begins. The distance between the two, the whole width of the transition that ended an age, is often no greater than the span of a hand. 12 centuries of cold, the extinction of a continent's giants, the reset of the human story, all of it pressed into a layer you could cover with your palm. There is no other place in the record of the earth where so much consequence is folded into so little sediment, so close to the surface, so close to us in time. And the deepest strangeness of standing before it is not the drama of what it records, but the silence of it. The way the layer offers no explanation, no label, no cause, only the fact of the division itself, before on one side and after on the other, and between them a darkness that has kept its secret for 12,800 years and shows no sign of giving it up. Every theory in this story is an attempt to explain that hand's width of dark earth. None of them has yet succeeded past all doubt. The layer remains, patient and mute, the physical signature of a question that has outlasted every answer proposed for it. And the flower, the small white flower whose name we gave to the whole ordeal, still grows. Dryas octopetala blooms today in the high cold places of the world, on Arctic slopes and alpine ridges, and the stony margins where glaciers have only recently withdrawn, indifferent to the role its ancestors' pollen played in naming an age. It doesn't remember. A plant carries no memory of the cold that once favored it, no knowledge that its buried grains in a Scandinavian lakebed became the marker by which human beings would identify the strangest interruption in the whole warming of the world. It simply grows where the cold allows and waits where it does not, as it has for far longer than there have been people to name it. There is something quietly instructive in that indifference. The mystery that consumes so much human effort, the flower does not share. The catastrophe that may have ended a world and begun our own is, to the mountain avens, merely a description of the temperatures it prefers. And perhaps that is the truest scale on which to hold all of this, not the human scale of urgency and argument and the hunger for an answer, but the longer, slower scale on which flowers outlast civilizations and dark layers of Earth keep their counsel across the millennia, and the sky wheels overhead, dropping its rare and terrible visitors on a schedule no single life will ever witness. The flower blooms, the ice remembers, the question waits. And somewhere beneath all of it lies the thing that stopped the world, still unnamed, still holding the shape of a wound we have never been able to see the whole of.
It is worth remembering, as the mind begins to loosen its grip on the day, that the calm we live inside is not the ordinary condition of the world, but the exception. The long stability of the last 11,500 years, the reliable seasons in which every harvest and every city and every generation of human memory has been raised, is a single quiet interval in a climate record that is otherwise jagged and violent, lurching between states with an abruptness that would be terrifying to live through. The Younger Dryas was the last of those lurches before the calm, and it demonstrates, with a clarity that few things can, how quickly the world can change its mind. Within years, not centuries, the Northern Hemisphere reorganized itself twice, first into the cold and then back out of it, and the people alive at the time had no more power to prevent it than to prevent the turning of the sky.
We tend to imagine the climate of the Earth as a stable backdrop against which history unfolds, a fixed stage. The deep record says otherwise. It says the stage itself moves, sometimes slowly and sometimes with a speed that outruns any human response, and that the long steadiness we were born into is a gift whose duration is not guaranteed by any law we understand. There is no need to carry alarm into the quiet of the night. The great moods of the Earth move on a scale that dwarfs any single evening, and the cold that this story circles lies 12,000 years behind us, asking nothing of the mind that turns it over now except a little wonder. The point is not fear, but perspective, a sense of how thin the ground is on which everything familiar rests. The warm world that feels eternal is an interlude, bracketed on the near side by the cold that this whole story circles, and it is worth a moment's wonder that we happen to live within it, in the calm after the last great lurch.
Drawing breath in the long exhale that began the moment the Younger Dryas released its grip.
And in the end, the event teaches something about forgetting, which is perhaps the deepest lesson the past can offer. Here was a change vast enough to reset a hemisphere, to erase a continent's great animals, to reshape the human story, and it happened not in some unreachable geological abyss, but recently enough to touch our own ancestors. Yet it faded. It faded from memory almost completely, surviving, if at all, only as the ghost shapes of flood and fire in the oldest myths, until the flowers in the lake beds and the metal in the ice brought it haltingly back into view. If an event of that magnitude could nearly vanish from the human record, could dwindle to a dark line in the dirt and a scatter of contested grains, then how much else has happened that left no line at all? How many endings and beginnings, how many worlds that felt as solid to their inhabitants as ours does to us, have passed entirely out of knowing, leaving not even a seam in the earth to mark that they were ever there? The Younger Dryas is remembered only because it was written, by chance, into materials patient enough to keep the record, ice and pollen and stone. The vast majority of the past enjoyed no such fortune. It simply happened and ended and was forgotten, and the silence closed over it as the rising sea closed over the coastlines where the people had lived. To sit with the mystery of the last age is to sit at the edge of that silence and to feel how much larger it is than everything we know, and to understand that the darkness holding this one unanswered question holds, beyond it, an ocean of questions no one will ever think to ask. Consider gently, and without insisting it is true, what the moment itself might have been if the sky was indeed the cause. On some ordinary evening at the end of the last age, a band of people somewhere in the northern world would have been going about the small business of survival, tending a fire, cracking marrow from a bone, watching the light fade over a landscape just beginning to green after the long ice. they would have had no reason to look up. And then perhaps the sky changed. A light where no light should be, growing, brightening past the moon, past the sun, until the whole dome of the heavens flared white and the shadows on the ground ran and swung. A heat like the opening of a great door. A sound that arrived after the light, if anyone lived to hear it, a roar that flattened the reeds and shook the ground. And then, in the hours and days and seasons that followed, the slow descent into a wrongness that no one could name, the sky staying dim, the warmth not returning, the plants failing, the animals thinning, the world sliding into a cold that the old ones would swear had never been so deep. If it happened at all, it happened to people exactly as capable of terror and wonder as anyone alive tonight. People who loved their children and feared the dark and told stories around the fire, and who would carry the memory of that night, if they survived it, as the most terrible thing that had ever been seen, passing it down until the passing failed, and the memory blurred into legend, and the legend at last into silence. This is imagination, not evidence, and it must be held as such. But it is the human face of the abstraction, the reason the grains and the dates matter, and it is worth carrying into sleep precisely because it may not have happened this way at all, because the ocean may have done its quiet cold work with no light in the sky, and no night of terror, only a gradual and unremarked slipping of the warmth.
We do not know which world our ancestors lived through. We know only that they lived through one of them, and that whichever it was, they endured it, and we are the proof. The mind, drifting now, might rest on the simplest version of the whole matter, the version that survives when all the argument has quieted. Something stopped the world 12,800 years ago. The warming halted, the cold returned, the giants died, the hunters scattered, and a thin dark line was drawn across the record of the earth. And after everything, all the cores drilled and the boundaries sifted, and the craters sought and the pillars read, we still do not know what did it. The not knowing is not a temporary state awaiting the next discovery, though discoveries may yet come. It is, for now, the honest shape of the thing, a mystery held open not by ignorance, but by an abundance of clues that will not agree. There is a peace available in that, if one is willing to take it, the peace of a question that asks nothing of the person contemplating it, that will not be solved tonight or perhaps ever,
that can simply be held in the mind like a smooth, cold stone as the body settles towards sleep. The people who study it have made their peace with it in their own way, returning each season to the layers and the ice, adding their small measurements to the long accumulation, knowing they may not live to see the answer and continuing anyway, because the question is worth attending to whether or not it ever closes, and the rest of us who will never drill a core or sift a boundary can attend to it in the only way available to us, by lying still in the dark and letting the strangeness of it move through the mind, the flower and the ice and the metal and the seam, the world that stopped and started again and buried the reason beneath a hand's width of earth.
So let the question stay open, the way the night stays open above the sleeping world. Somewhere beneath the ground, under fields and cities and the ordinary places where lives are lived, that thin dark seam runs on, older than any memory, dividing a world we barely glimpse from the world we know. It asks nothing, it threatens nothing. It simply holds, in its hand's width of darkness, the record of a moment when everything changed and no one was able afterward to say why. There is a strange comfort in a mystery that old and that patient, a mystery that has waited 12,800 years and can wait 12,000 more, indifferent to whether it is ever solved, indifferent to the arguments raised over it and the instruments turned upon it. It does not need an answer to go on being what it is, and perhaps that is the gift it offers to anyone who lies awake turning it over, the permission to hold something unresolved without the ache of needing to resolve it, to let the not knowing be a place of rest rather than a wound. The scientists will return to their cores in the morning. The flower will bloom on its cold slopes, whether or not anyone comes to name it again. The sky will keep its slow and secret schedule, and the seam in the earth will lie where it has always lain, keeping faith with its silence. The world stopped once, long ago, and then it started again. And here we are on the far side of the door, in the long warm interval that the stopping made possible. Everything soft and familiar, the reliable dawn, the turning seasons, the very quiet in which sleep can be found, rests on that ancient recovery, on the abrupt and unexplained return of the warmth. We are the children of the after. We were born into the calm that followed the last great convulsion of the sky or the sea, and we have never known anything else, and it is easy living inside the calm to forget that it began, that it had a first morning, that on the other side of a thin dark line the world was a different and harder place. To remember is not to be afraid. It is only to feel for a moment the depth of the time beneath us and the fragility of the light we take for granted, and to be a little more awake to the wonder of an ordinary warm night. The answer may come in some far season, when a new instrument reads the old ice more truly, or the sea gives back a drowned shore, or a grain long overlooked turns out to hold the whole of the story. Or it may never come, and the world may keep this one's secret forever, folded into the earth beneath the reach of every spade. Either way, the mystery will have done its quiet work, which is to remind us how young we are and how much we do not know, and how much has already been forgotten. Let the mind rest there now, at the edge of the dark seam, where the warm world begins. Something stopped the world once. We still do not know what. And the not knowing tonight can be enough.